A little bit more in-depth look at a couple of these interesting components. So we talked about take-up on the belt. So we need some way to adjust the belt. So the way to take up the belt, the long belt that goes for the back here, is to run it around an idler. So the idler will take up that extra length, and this is the idler right here. And it's on an eccentric. There's a video of, it's a pretty interesting piece to make with the eccentric. So. This idler right here is a automotive part. It's for a serpentine belt. It just, luckily, it just happens to fit these GT belts, 30 millimeter GT belt, just perfectly. So no modification, just buy this right out of a box. It's already got the bearing in it and so forth. So you need to make a pin for it. So the reason for the eccentric, of course, is this goes into this hole. It's in the motor plate. Now, if I turn this from the back, you'll see that it traces around little circles. So you can imagine a belt going by this. When you crank it like that, it tightens the belt up. So you're able to tighten the belt without having to move the plate, move the motor. So that's what, and then you can of course you can loosen the belt in order to change the belt or move the belt to the other arrangement. So that is a fun part. This guy is really important. Some people have asked about what needs to be accurate, what doesn't need to be accurate. Some people are purists, and they want to go to a 10,000th of an inch on everything, sharpening a pencil. So my philosophy is, and this is after many years of talking to the actual machinists on the floor, finding out what does it actually take to make this part, because they're the fellows that really know. They know the machines, they know the materials, they know what it takes to get a part made, what it takes to get a finish on a certain kind of material. And I spent a lot of time on the floor with my tie tucked in, bothering those guys, trying to find out exactly what, if I design something, am I making something that's going to cost $1,000 to make or $100 to make. So sometimes you need the accuracy, and sometimes you don't. If you're drilling a clearance hole, if it's 5 thousandths bigger or smaller than ideal, it doesn't make any difference. So, and of course, the finish on the inside of a clearance hole doesn't make any difference. If you're starting a tap that's going to go through a piece of material, whether you're 10 thousandths high or low at the starting point, is irrelevant. This doesn't make any. It doesn't matter. You don't have to be that precise. If you're tapping into a blind hole and you're trying to get that last thread, then it matters. But something like this has to be true. The center lines, here's the case where you have to pay attention. It has to be accurate. So you spend the time where you need to be accurate, and then when you don't need to be accurate, you just fly. Just get it done as fast as you can. So the center line of this pulley has to be perpendicular. Has to be parallel to the center line of this. Otherwise, it's going to try to track the belt. And if it tries to track the belt, it's going to shred the belt on the edges. So your belts won't last long at all. So this has to be a nice, true alignment, and also this has to be perpendicular to this plate. It can't be angled off one side or another. So you can't have sloppy machining on this guy. It has to be nice, and everything has to be either parallel or perpendicular, depending. So we need a washer to go on the back side of this. And what will happen is, if there's not a lot of clearance in that hole, but there's some, and this is aluminum. So other than putting a hardened drill bushing in there or something else like that, we have to really rely on this thing to clamp up to that plate and be perpendicular. So this washer is going to go, it's going to backup washer, and if this washer is not parallel on each face and clean without bumps and grinds and so forth, then when you tighten the nut up, it's going to take this and it's going to move it. Just that little bit of clearance is in there, it'll move it. So this has to be flat on the back. This has to be flat on both sides and equal thickness all the way around. So this washer right here it's a big grade 8 washer, but it's been surface ground on both sides to make sure that it's flat, smooth, and the sides are parallel. So that goes on, and then this big old nut also has one side of the face of it has been ground perpendicular to the center line, so that when this guy goes together, it's going to pull up, and when, of course, you adjust it this way. So when this thing is tightened up, that shaft is going to be absolutely perpendicular to this plate, which is what we want. And no matter where you run it, so it's going to, you can run it around or move it somewhere else, and it's going to stay perpendicular. So that's a kind of an interesting part. The machining an eccentric is kind of fun. So there's a video on that. So we'll put that aside now. We've already gone through this rocking and rolling, so we'll put this aside. So now we have this is a kind of an interesting piece here.